Okay, and on to our walking talking mock for Chemistry 1, June 2014. So, scrolling down with the new iPad. Okay, we get to our first question. Fossil fuels contain carbon and hydrogen. Use the chemistry data sheet to help you to answer this question. So, it says complete figure 1 to show the electronic structure of a carbon atom. And so, you would need the data sheet for this, but I will just write it down. So carbon would look like this, and all we'd have to do is show the electronic structure. So that means we're going to be drawing electrons, and they've helpfully drawn two shells, which is what we're going to need. 1A part 2, complete the word equation for the oxidation of hydrogen. Now that makes it sound complicated, but we've got hydrogen and oxygen, and we just need to think of a chemical that includes both hydrogen and oxygen. Okay, so almost like this, and what could that form? Moving down, we've got coal is a fossil fuel. Coals contain the elements hydrogen, sulfur, oxygen, and carbon. Name two products, so that's really important, of burning coal that have an impact on the environment. What impact does each of these products you named have on the environment? So, reading this question straight away, I'm going to split this into two parts. Okay, so I need my two products. And each of those two products is going to need an impact. Okay, so we're trying to get these 4 marks, and I can guess the mark scheme without looking. Says product 1, product 2, impact of product 1, and impact of product 2. So I'd be thinking, right, there's a clue in the question by the names of the elements. So we've just got to come up with two products of burning coal that may have an impact on the environment. So straight away I'm going to look at carbon and oxygen, and something could form from that. Second thing, I'm going to look at sulfur and oxygen. Because again, we could form something from that. And we need to explain the effects, not in terms of pollution, because pollution doesn't really get us any marks. It's not specific enough. So I need to explain the impacts in terms of, for example, global warming would be a specific impact. Moving down. Ethanol and vegetable oil are used as fuels. This is question 2. Okay, so we're on to a different topic now. There are 2 different ways to produce ethanol. That's using ethene from crude oil and using sugar from plants. Okay, so ethene from crude oil, sugar from plants. Ethanol is produced from ethene by hydration in the presence of a catalyst. What is hydration? And for this question, we are going to answer it in quite simple. So we don't really need to say anything more complicated. So hydration is always to do, if we think about us and our daily lives, it's water, and it's when we add water, okay, or react with water. So really straightforward. We don't need to look too at that in a complicated manner. Fermentation is used to produce ethanol from sugar by dissolving the sugar in water, adding yeast, and yeast are really important, to the sugar solution. So we've got sugar and yeast, and leaving the mixture for 3 days. Okay, and it shows some 3 days. Okay, so we've got water and ethanol, and solid waste yeast. Okay, so right now it wants us to suggest how the solid waste yeast is removed, and how ethanol is obtained from the solution. And that solution, remember, contains water and ethanol. Now we've got a problem here because water is colourless, ethanol is colourless. They're both liquids. So therefore we need to think of a method that's going to separate them by something else. And they have different boiling points. Water is 100 degrees C. And ethanol is around about 78. I wouldn't expect you to know that, but you do need to know they've got different boiling points. So we can separate those based on boiling points. So we're looking for a method based on boiling points, and there is such a method. Perhaps the easier one, okay, is removing the solid waste G. So if we've got a solid and we've got a liquid, we can quite easily set up a piece of equipment like this. The solid will be trapped here, and the liquid will move through to the bottom. Okay, so again, we need to give that a name. So we're essentially looking for two keywords, and we've got to make sure we say which one's which. Now we come to our 6-mark question. The 6-mark question in this one is fairly detailed. There's a lot of information. What I would say is when there's a lot of information, it means that you are probably going to be able to use quite a lot of this in your answer. So we'll read through it carefully, how anything creates. So crude oil is separated to produce the fraction petroleum diesel. Worries about low supplies of crude oil have led to the growing of large areas of crops to produce vegetable oil. Okay, so we grow crops and they produce vegetable oil. Vegetable oils are also used to produce biodiesel. Okay, so we've got crude oil, petroleum diesel, vegetable oils, biodiesel. There are economic, ethical, and environmental issues about the use of biodiesel. Firstly, we need to know what these words mean. So, economic means to do with money. Oops, I'm writing out the same word, money. Ethical is to do with morals. And environment is fairly straightforward, to do with the effects on the environment. So, biodiesel and petroleum diesel are used as fuels for cars. They're both fuels. Oops. Okay, in a car engine, the fuel burns and releases waste products. I guess it would be those waste products that cause any pollution through the car exhaust system. Table 1 shows the amount of waste products formed by biodiesel compared with the amount of waste products formed by petroleum diesel. And we've got ppm as parts per million, but that's not really going to be important. So we're comparing here. Okay, so we'll find out what the question is going to ask us to do, and then we'll have a careful look at that table. So use this information. Now, there's a couple of things here. Use this information and your knowledge. So that's saying two things. You can't just rely on what you know, and you can't just rely on what's in the question. You've got to give something from both. To give advantages and disadvantages of using biodiesel instead of petroleum diesel. So, I would probably be thinking a few things. Okay, so I'm going to use pollutant information from the table. Okay, so that's going to come from the table. I'm going to use information about renewable or non-renewable. And that's going to be from my own knowledge. And then I'm also going to use a bit of my own knowledge to then follow on from what the table says. So a bit of my own knowledge there. So we'll do an example, but first we'll look at the table. So we can see, for example, let's have a look at carbon dioxide. You can see biodiesels, 20,000, petroleum diesels, 80,000. Now if we just stated those figures, biodiesel is 20,000, petroleum diesel is 80,000, we would get no marks because we are not actually saying anything of value. Okay, so what we'd have to do is say, for example, I would make sure we included the words advantages and disadvantages. So we might say something like advantage of biodiesel is less CO2 produced. And then therefore we could say, therefore there will be less effect on global warming. Okay, so what we're doing there is we're saying an advantage. We could also say disadvantage, and we're saying the effect. So we could work through several of these things. We could then look at nitrogen oxides. Okay, we could compare them. These are pretty similar in this case, but we could say this biodiesel produces more. Okay, it's slightly higher. I'd almost go through like this. And then really we want to be saying the effects of these things. We don't just want to be leaving it at a simple comparison, because if we don't say any linked consequences, e.g. global warming would be a linked consequence, we can only get a maximum of level 1, which is 1 or 2 marks. So with these questions, you use the information there, but you've also got to use your own knowledge. Okay, in this case it's knowledge about the effects of pollutants. Okay, and we move on. A lot of extra space. And we come to this question about cooking oils. So cooking oils contain unsaturated fats, and just to remind ourselves, unsaturated fats are those ones that contain carbon double bond. Unsaturated fats are more healthy than saturated fats, and now this is important, they're actually giving us some information that they've often asked before. So unsaturated fats change bromine water from orange to colourless. Scientists from a food company called Veggio, big up the veggies, wanted to find out about the amount of unsaturated fat in cooking oils. Scientists tested Veggio's own brands of oils and oils from 4 other companies. Scientists used the same volume of oil, so we've got a control variable there for each test, and the results are shown in table 2. So we'll have a look at this table. But firstly, the first question doesn't really even need the information from the table. So describe how bromine water is used to obtain these results. Okay, because it's a describe question, we're just going to literally say what happens. So how the bromine water is used to obtain these results? Well, it's essentially a practical procedure. So it's almost like stage 1, stage 2, stage 3. And you've just got to know how you use bromine water. Okay, I mean it's very simple, drop by drop, and then you see what the result is. And they've already given you part of the result up here, because what you're looking for is for it to change colourless. So there's a lot of information there in the question. And then it says choose one result from table 2 that should be tested again. Okay, company and test. And then why did we choose this result? So for this we will look along the line. So Veggio 14, 13, 16. Doesn't look anything unusual there. Company A, well there does look something unusual there. Company B, nothing unusual. Company C, nothing unusual. Company D, potentially something unusual but not massively different. So I'd probably be going with the one that seems to be the most unusual, which is this one. And then I'd be saying why I'd be choosing that. For that, because this is essentially a practical question, I'd be using the same type of language we use in the ISA. Now I mentioned before that the same volume of each oil was used. Okay, so that was a control variable, and it says suggest one other variable, so we can't use the same, that should be controlled in these tests. Okay, so we've got to think these tests. How do we control it? So the obvious thing would be to think about the bromine. Now we're going to be varying the number of drops we add, so we can't say the volume, but we can always say something else about the bromine water, similar to what we can about any acid. Then we move to the final bit where we are going to need the table. In particular, the veggie or food company claims that its cooking oil has more unsaturated fat than other cooking oils. Compare the results for Veggio's cooking oil with the results of other companies. Give 3 conclusions that can be made from these results. Okay. So, for this, really, we need to know something that should be quite straightforward, but we might not know. Okay. So, more drops needed equals more unsaturated fats. So then we're going to look up at the table and we're going to compare them. So firstly, I do almost like a rank order. So this one seems to have the most unsaturated fats. This one's second, third, fourth, and fifth. And then I'd be comparing them. So I could say something like A has the most, D has less, C has the least, etc. So we're making very simple conclusions, but that's all we have to do. We just have to use the information in the table and just analyse this, okay, to come up with some very, very straightforward conclusions. Then we move on to question 4, which is a question about metals and extraction of metals. So we start off with copper ore where copper ore has been mined. So we're talking about copper ore. There are areas of land that contain very low percentages of copper compounds. One way to extract the copper is to grow plants on the land. Okay, plants absorb copper compounds through their roots, and the plants are burned to produce copper oxide. Again, it's another question. There's a lot of information in there. This is a process called phytomining. And I've just given the answers to the first question, but you can see you just have to sometimes just know very, very straightforward answers. So you've got one for free there. The copper oxide produced from plants, just reading back in the question, copper oxide produced from plants can be reacted to produce copper or copper sulfate, and then we've got our 2 kind of pathways here. Okay, so if it's added carbon and heat, you'll produce copper. If you add sulfuric acid, you produce copper sulfate solution. And then we get here, suggest 2 reasons why copper from these areas of land is not extracted by smelting. Okay. So we need to know that smelting is essentially just heating the ore with carbon. And the key word there is probably heating. So if we have a look up, one of the things, okay, is that there are very low percentages of copper compounds. Okay, so because there's very low percentages, okay, we've got to think: is it worthwhile? So now, if it's not worthwhile, we've got to think why it's not worthwhile, and it's probably not enough money in it, and we can come up with a word that is uneconomical. Okay, so we'd put that in terms. Question 4a, balancing symbol equations. So balance the chemical equation for the reaction of copper oxide with carbon. Okay, so first thing, we have got some blanks here. Okay, this one here is for balancing. Where you see a longer one, it's for writing the name of a chemical. In this case, the formula of a chemical. So let's think. Okay, we're getting copper and the carbon and the oxygen together, and they're forming the CO2. So we are left with copper. Okay, so we'd write that down there. Okay. And then we'd have to balance it. So just as always, we split it down. Okay, 1 Cu over this side, 1 C, 2 O's on this side, 1 Cu, 1 O, 1 C. So we can see we need more oxygen. So we'd start here. Okay, and then we'd continue that process until we've got equal numbers both sides. Next, okay, so we get to a question here. We're getting to the harder questions now. Copper is reduced from copper sulfate solution by displacement using scrap iron or by electrolysis. Use the chemistry data sheet to help you answer this question. And it says, and that's very important because we're going to need that. It says give 2 reasons why scrap iron is used to displace copper. Okay, so 2 reasons. So, firstly, if we have a look at the chemistry data sheet, we'd have copper here, and then we'd have some really unreactive metals like silver and gold, and then somewhere above copper we have iron, Fe. Now, this all relies on reactivity, so we can use metals that are more reactive to displace. Okay. The thing is, there might be other metals. We might have something like zinc up here, and we've got to think of their relative values. Now, zinc is an expensive metal, relatively. Iron is very cheap. So we'd have to use that to help us. You know, same with some of the other things up here. So we might have calcium. Again, more expensive. So we've got to relate it to the reactivity series. And we've got to relate it to cost, okay, because we're trying to get our 2 marks, okay, we can't just say one thing. And then we get electrolysis. Now this should be fairly straightforward because we've done C2, and the electrolysis in C1 is much, much easier. So it shows the electrolysis of copper sulfate solution. Got a negative electrode, negative electrode, and we've got a positive electrode. And this is the electrolyte, the copper sulfate solution. Describe what happens to the ions during electrolysis. So I'd be tempted to take my 2 ions, okay, and firstly I would say, oh sorry, it's just copper ions. Now there's a point in reading the question. So I'd say where copper ions go to, okay, I might say why, okay, and I'd say what happens to them. So they're Cu2 plus. What are they going to need to gain to become copper atoms? You could even include that in an equation, but I would do a description because it wants a description. Okay, you could do an equation, but do a description. Question 5, limestone. Contains calcium carbonate, which we all know. Again, they're providing us with a lot of information in these questions. Name the type of reaction that takes place when calcium carbonate is heated strongly. Name the products formed. Okay, so we're going to get 3 marks here for 3 separate things, essentially. Okay, so a lot of marks, okay, not a lot to write. Sometimes the space is deceptive, so we need to name the type of reaction, and product 1 and product 2. Okay, so I mean, we don't know that many types of reactions. Okay, so there's things like displacement reactions, etc. But this is heated. Okay, so it's going to be a decomposition reaction, a thermal decomposition reaction. And the second part, if you don't know this, we can just think calcium carbonate. What could we possibly break that down into? Well, often CO2 is released, so we could have that, and we could have something else. Okay, we could keep it as symbols. If we weren't sure, you could have a guess at symbols, so you could say CO2 and whatever's left. There's no reason why you have to write the words, okay? So you can have a guess. Next one, a student investigated what happens when limestone is heated strongly. It's the method used. Measured the mass before, measured after, and repeated. Okay, so we got this. Now it says calculate the mean mass loss. Okay, taking account of any anomalies. Now we know from ICES we exclude anomalies. So mean mass lost. Okay, we've got these values at the bottom, so we need to read the careful. This is the mass loss. So these are the values we're going to use. We're going to look through. If it says taking account of any anomalies, even if it doesn't, to be honest, we're going to look for them. But that's given us a massive clue, so we're going to exclude this one, which is our anomaly, and then we're going to work out the mean of the others. Fairly straightforward. Student used the chemical equation to calculate the maximum mass lost by 5 grams of calcium carbonate when heated. Maximum loss is 2.2 grams. Suggest and explain 2 reasons. 4 marks. Okay, so it's the suggesting and the explaining. Okay, for 2 of them, 1 each. Why the mean mass loss in the experiments to heat limestone is less than 2.2 grams. Do not include any reference to weighing errors in your answer. Right, now this is a tricky question. Okay, so we can't rely on this idea. Okay, that we might not do. Okay, so firstly we've got to think thermal decomposition. Okay, it's all about heating. One reason why one might not decompose as much as another and therefore produce as much mass loss is because the temperature is less. Don't know why I put that arrow. So we'll think about that. That'd be our obvious one. Okay. And then we'd think about calcium carbonate itself. So calcium carbonate formulas that, and it is very rare that you will end up with every single compound in there being that. So you would have impurities, and then we'd think about the effect of impurities. Okay, just like in ores, we always have impurities, so there will be other things in there. Next one, structure of the Earth. The Earth is almost spherical and surrounded by an atmosphere. Figure 5 shows a section of the layered structure of the Earth. So we've got X, Y, core, centre of the Earth. In 1915, Wegener put forward his idea of continental drift. Why did most scientists in 1915 not accept Wegener's idea of continental drift? Now, a lot of you will probably go to like standard arguments like God, which wouldn't be allowed, or no proof. Again, which wouldn't be allowed because he did have some proof. Okay, actually had quite a lot of it. What he couldn't do was explain how it occurred. You could see it did occur, but he couldn't explain how. And that's what we'd have to say. Next, so describe how and explain why continental drift takes place. Include the names of X and Y in your answer. So if we go back up, we've got X equals and Y equals. We'll probably get that in straight away, and we'd have to include it in our answers as well, but I'd write it down and make a point. Okay, so we'd start off with the idea of probably tectonic plates, and then we'd work our way into why they move, okay? And because it's a longer question, I will be thinking of some keywords. So some of my keywords are radioactive processes. That's what's happening in the core. radioactive decay essentially. Convection currents. And Mansell. Okay, and obviously tectonic plates, which I've already mentioned, but I should have put in here. There we go. So we'd be thinking about these things. Now this is a hard question. Well, it's not actually, the science isn't that hard, but it's one of those obscure areas of the spec. So what we'll try and do is we'll try and get as much information as we knew. So if we couldn't get all 5, we'd make sure we mentioned, you know, the name of X, the name of Y, this idea of tectonic plates, and if we're really struggling, we might leave it there. But hopefully by that point you'll be pretty good at this. Then we have some properties of gases in the Earth's atmosphere. Okay, and it's on about separating them. So it says they're separated by removing CO2, cooling the remaining gases to -200, removing the gases that do not condense, i.e. that are still gases, and allowing the liquefied gases to warm up. Okay. Suggests one reason carbon dioxide is removed before the gases are cooled to -200 degrees. Well, if we have a look at carbon dioxide, it basically melts and boils at the same temperature. So if we cool it down to -200, it won't become something we can use, like a liquid that will flow. It will become a solid. Okay, next part of the question. Draw a ring around one gas that does not condense when the remaining gases are cooled to -200. So we'll use our table, okay, and we can see boiling point is the one we're interested in, because if it's so, yeah, we're interested in the boiling point, so this column, because if it goes below the boiling point, below that, then it will condense, so it'll turn from a gas to a liquid. Now we've got 4 gases. Start off with argon. Well, -200 is below argon's boiling point, so we won't be using argon. Neon. Now neon's boiling point is way below -200, much lower, so it would still be a gas. So we would be going with neon. Nitrogen, again, just above -200, and oxygen, just above -200. Helium would also be a gas, but that's not part of the question, so we can exclude that one. Right, okay. The oxygen separated by this process contains another gas. Name the gas, okay, and give a reason for your answer. So again, we're going to use the table. We're not going to expect that we know this, okay, so we're going to have a look at oxygen, which is across here. -219 and -183 perhaps, or 193, can't quite see. Okay, so yeah, it's 183. Okay, so we've got -183. Now if we cool it down to that, cool it down to -200, then start warming up, at this point, -183, we're going to get oxygen produced, okay, as a gas, but also we might get argon produced because the difference in boiling points is minor. So what you might find is you get both produced at the same time. Again, another tricky question, that one. And so we move on to our final question, organic chemistry. And it says polybutene is a polymer made from crude oil in 2 stages. First stage in making polybutene is to break down large hydrocarbon molecules from crude oil into smaller hydrocarbon molecules. Okay, so we're taking this crude oil and breaking it down. So here we've got our large molecules, okay, and here we've got our smaller molecules after the reactor. Okay, so it says name the two types of hydrocarbon. Okay, so those, there's actually more than that, but for your purposes. So two types of hydrocarbon. Okay, so we'd be thinking of the two things that only contain hydrogen and carbon. Okay, and there's two groups. Okay, so we're looking for two groups, and that's what we'll name. Describe the conditions in the reactor. Okay, well, in order to break these things down, in order to make roast reactions going, we're going to be thinking about temperature. And then we're going to be thinking about how do we speed this reaction up. Okay, so we need to be thinking about catalysts. And you might know the specific catalysts, but I think we could get away with this one with just saying catalysts. Then it says suggest why air must not enter the reactor. Okay, so if you get air in, okay, air contains oxygen. And if oxygen gets in, what problem might it cause, say, if it gets near this? What might happen? Okay, so we've got to think, you know, it's a suggest question, so we've got to think very carefully about what might happen. Okay, we're making a suggestion. Then it says suggest a method that can be used to separate butene from the other hydrocarbons. Okay, so we've got butene up here. Now, all of these products and many, many more, they can be separated, okay, in a column. Okay, and we need to know the name of this column. Alright, well, we've got something that looks like this. Okay, so that's the method they can be separated. Okay, if we're thinking hydrocarbons, we're thinking this method. Right, okay, so second stage, to use butene to produce polybutene. Draw the spread structure of butene in a CH4A molecule. Okay, really straightforward. Some rules. Carbon always bonds 4 times. So with these, we'll draw our 4 carbons. Now, because carbon only bonds 4 times, and we've got 8 hydrogens, we're probably going to draw our hydrogens up here. Sorry, ignore that. Okay, so we've got our C4H8. Okay, but then we've got to think, are we right with this? So what we do then is we count our bonds. Okay, so every hydrogen has got 1 bond, so the hydrogens are right. Then we're going to look at our carbons. So this carbon's got 4 bonds. 1, 2, 3, 4. This carbon has 4 bonds. 1, 2, 3, 4. This carbon has 1, 2, 3. And I've just realised that I've done this wrong because the bonds aren't going to add up. So what I'm going to do is I'm going to take that hydrogen from there and put it on there. So now this carbon has 1, 2, 3, 4. And my one at the end has 1, 2, which is completely wrong. Okay, so again, I'm going to have to move another hydrogen, and this is what you can do. You know, you can just keep working it out until we get it. So I'm going to put that one there. Now, what we have here is a situation where this carbon now has 1, 2, 3, and this carbon also has 1, 2, 3. So what I'm going to do is I'm going to put in a double bond here, and that will make sure that this carbon has 1, 2, 3, 4, and this carbon also has 1, 2, 3, 4, and then I'm right. Okay, so you just got to work through it using your rules about hydrogen forming 1 bond, carbon forming 4 bonds. And then finally we get a question that is asking us how polybutene differs to butene. So for this one, butene is what we call a monomer. Polybutene is a polymer, i.e. this thing makes up that thing. Okay, so we'll just make a comparison between them. So if it's a polymer, we're going to think about size. I'm going to think about what it's made up from. And we know that it's made up from this monomer, okay, butene. Okay, but it's making poly, meaning many butene. Okay, and that is it.